Hello friends, welcome back to Go Tutorials. Today we are going to see much more details about channels. In the previous section, as a part of concurrency API and concurrency programming, we have seen something called Goroutines, right? So now we are going to see something called channels. So we know how to create a Goroutine, how to call a Goroutine, right? Now we are going to see channels. So what are channels? So channels are nothing but pipes through which we can send data to Goroutines. So if we want to pass, we can pass. So if we want to pass some data or something to a Goroutine, it can be done through channels. So first let us see how to create a channel, then how to pass value to a Goroutine using a channel. That is very much important, right? So these are all the important things needs to be known in the concurrency programming. So channels is the first thing. So now what we are going to do, we are just going to create a simple channel and how to use those channels and all. We are going to see, right? Opening a command prompt, going to our Go demo folder, channeldemo.go. I am naming this file. So as usual, package main, function main. So here import fmt. So as usual, a simple code we have written. Now I am going to declare a channel. So before that, we know channels are pipes. The pipes can carry data, right? So as usual, how we declare variables for arrays, functions, everything, we can declare channels as well. How to declare a channels? Var. So this is how the same way, right? I will increase the font size. Yep. So I am going to use the var variable. Using the var variable, I am going to declare it as my channel. I am giving some name to my channel. So this is a variable my channel. What is this variable is all about? This is a channel. So there is a keyword called chan which represents a channel. So what I am doing, I am going to create a variable my channel which is a channel of type. So which type of data the channel can pass to the Goroutines? I need a channel of type integer. So what does the statement says is the statement declaration of my variable my channel as an integer channel. So it is a channel, it can carry integer values, it can pass integer values to the Goroutines, right? Now what I am going to see is, as usual, format.Println. If I try to print my channel, say go run channel demo, nil, because we have just declared the channel is not being initialized, so it is printing it as nil. So now I am going to initialize it. So let us handle the nil value, my channel not equal to nil, right? Sorry, it should be, if it is a nil, we can panic again, we can raise a panic, or we can say something channel not initialized. Okay, now what I am going to do here is, so if I run the code as usual, it is null, so it is telling channel not initialized. Now I am going to initialize the channel here. So how to initialize the channel? So already we have seen a function which is used to instantiate any type of object, which is make. So using the make, what I am going to do, I am going to initialize a channel. What is the type of the channel? Integer. So this is the syntax we need to follow. We can use the same to the variable my channel. So now I am instantiating or creating the int channel. This is to my channel. Now what I am going to do, I am going to print it as format.Println my channel. So if you just declare a channel, it returns null. if you create or instantiate a channel, let us see what it is being printed. See here a hexadecimal value representing the channel. So the channel, this is the number which is representing the channel. We are not interested with this, but this is just to showcase how to create a simple channel and how to instantiate a channel. So this is how a channel creation is in Go programming language. Now, what to do with this channel? I am already done with this channel now. I have created something with this channel. Now, what I need to do with this channel? Okay, so there are two types of operations we can do using a channel. So we can send values and receive from the channels, because we can pass data between Goroutines, right? So we can send and receive data from a channel. So how to send data from a channel and how to receive? So there is an operator less than equal to, using which we can send or receive data from and to the channels. So how to send a data, how to receive a data? So if we want to read data from a channel, so we need to specify the channel here. So the arrow implies we are reading from the channel. So where we are reading? So I am reading to my local variable. So I am reading to the data. This is the variable I am using. So this is a statement we use to read from the channel. So how to write the data to the channel? That is also important, right? So the data will be written to the channel. So channel, which data I am going to write? So some other variable. So the data flows towards the channel. So see here, the arrow flows towards the channel. Here the arrow goes away from the channel and towards a variable. So if the arrow goes away from the channel, that means we are reading from the channel. Similarly, if the arrow goes towards the channel, we are writing to the channel. Writing to the channel. Of course, this is not the way. Now if I compile and run the code, it won't execute. It won't execute for now. There are some errors. This is just to give you an introduction. These are all the ways we can write and read from the channel. From the next program, we will see how to write data and how to read the data from channel. So this is just to showcase there is a mechanism through which we can write data into a channel and read the data into a channel using the arrow operator. So if the arrow goes away from the channel, it means we are reading from the channel. If an arrow comes towards the channel, we are writing to the channel. This is what you need to know about in this particular example. So this is not to showcase, this is not to demonstrate read write operations. This is just to give an introduction on how we handle the read write syntactically. The next example we are going to see will have everything in its place, right? So let us go to the new demo.go. So as usual, the same thing I'm going to do. Package main, function main. Yes, interesting. Now import format. Here fmt.Println, I am giving the word inside main. Now I'm going to write one more function, the same go routine we discussed in the previous class, right? So previous video, the same thing now I am going to do now. Display go routine. So now what I'm going to do, go display. So what will happen if I compile and run the code? If I compile and run the code, it will print only inside main, because the go routine runs in a separate thread. Main will be returned before the go routine, so the go routine response will not be printed to me. So usually how we will do, go run new demo will give me only the content in the main. So in order to keep main waiting for the go routine to return back, what we will use, we will use the time package. So time.sleep, so we will make the go routine, we may make the main routine sleep for a second, then afterwards the go routine will be written. After the go routine returns from the execution, the main will be called. So both the response will be printed to us. We have seen the same in the previous class. Now what I am going to do, I am going to use channels. I am going to use channels to pass the values for the go routines. So we know we have go routines. To the go routines we used to pass the values, right? Now I am going to have some channel created in my main. So let this as it is, let this remain as it is. Now I am going to create a channel. make. I am going to use the make keyword. So what type of channel I am going to create? I am going to create an integer channel. So make chan int. So I am assigning to a local variable which will be my channel. The same way, right? So this is my channel. It is an integer channel. So I am instantiating or creating an integer channel. So I am done with the channel. Now what I am going to do is I am going to pass my channel from this goroutine to this goroutine display. So how to pass this to the goroutine? Simply specify the channel as an argument. So there in display I need to receive it. So how to receive it? Sorry, my channel, which is a channel of type integer. So from main I am instantiating an integer channel and passing into the display function. So what does this display goroutine needs to do is this will put some value inside the channel. Now what we are going to do, we are going to write something to the channel. So what I am going to do here, I am going to add something. My channel, this is an integer channel, right? So I am going to write some values to the integer channel. So writing the value 10 to the int channel my channel. So here what I am doing, I am writing something to the channel, right? So after this go execution, what I am doing now is I am going to read from the channel. So my channel is my channel name. I am going to read something from the channel. So I am not interested to assign it to any of the variables, but just I am reading it here. Now I just want to say you some of the important concepts of implementing channels here. Just I will execute the code. You will see the difference now. Display goroutine inside main. Both are being printed. See here, display goroutine. The goroutine is also being printed and main is also printing. But we are not having any sleep statement in place here. But still it is being printed. Why? Because usually as per the general characteristics, the main function will terminate main goroutine, right, in its last statement. So it will create a channel, the goroutine gets invoked, then automatically the code is completed and main should exit, because we don't have any sleep statement placed here. There is no sleep statement. But what we are doing here is we are reading data from channel my channel. So as per Go concepts, what will happen is whenever a channel read is happening, the Go compiler will wait, will keep the flow blocked until a write is being happening on the channel. Remember, whenever a value being read from a channel, Go runtime will block the execution until a value gets written to the channel. So if you are trying to read something from the channel, there must be something written to it, then only it will be read from the channel. So here what will happen, the Go compiler will first create the channel, invoke the Go routine, then comes to this particular line. In this line, the Go compiler knows we need to read data from channel, but it blocks the execution. So what it will do, blocks the execution until a write happens to the channel. So here the Go compiler will keep on waiting until there is a write operation is happening. So here, so when the Go routine performs, then we are writing something the values to the channel 10. Then automatically after the value being returned to that particular channel, this particular channel, that block will be released, then the main will be exited as usual. So this is what a blocking operation used by channels in Go programming language. Earlier we are using sleep statement to keep main purposefully waiting for the execution to complete. Now instead of sleep, what we are doing is we are creating channels. These channels will replace the operation of sleep and keeps the execution blocked until some certain operations are being performed. If the desired things are done, then automatically the main will complete its execution. So this is what we are seeing as an output here while running the code. So display go routine. This is what happening until the channel read is being waiting for the data. Once display go routine is completed, the data being printed, then automatically the main go routine continues. So this is what happening here. Now for an experiment, what I am going to do is I am going to disable the writing statement. So now we are reading the data from a channel, but we are not writing at all in the code. What will happen? What will happen? So there is no write operation is being happened inside the main routine or anywhere, even in sub go routines, anything for the channel, but read operation is there. If I compile and run the code, you can see an error. What the error is telling, all go routines are asleep, deadlock. So there is a situation which may cause deadlock. So this code will not execute. Why it is a deadlock? Because the go routine keeps on waiting for any data being written to the channel. So there are chances for the go routine to go for a deadlock. So this code will not get executed. That is what it is complaining. So if there is a read statement given, then there should be a write statement also will be there. So if we are reading data from a channel anywhere in a Go program or a Go routine, we need to have some write statement which complements or which supplies or which provides data to the same channel. Otherwise it will end up in deadlock, the code will not compile. So this is a very important concept we need to know whenever handling with channels. So if there is a read operation from a channel inside a Go routine, then there should be a proper write operation to supply data to the channel. Otherwise Go compiler will raise a panic of deadlock. So this is a panic. This is a panic in nature. This is a panic in nature. We can see here fatal error. It's a deadlock. So this type of panic needs to be avoided. So in order to avoid this, we need to keep the channels free from deadlock. That is, whenever it waits for reading, we need to supply the value to write. So that is what important here, right? So if we comment this statement, it goes for deadlock. Now for a change, what I am going to do is I am commenting the read line. So now I am not going to read from the channel. So there is a write operation going on here, but I am not going to read. What does it mean? If I disable the read operation, the blocking will be removed. That means the the Go compiler will not wait for the write operation to happen. That means there won't be any blocking calls. That means the main will not be blocked for any reason. That means there is no sleep operation is there, because earlier we had a sleep operation which helps us to complete the Go routine and come back to main. Now we are complementing the sleep operation with the channels. So the channel keeps on waiting until the other channel provides the value. Until the Go routine provides the value. If Go routine provides the value to the channel keeps on executing and the main Go routine also continues. Now the channel is being supplied with some values. Here in this Go routine, the channel is being supplied with some values, but I am disabling reading the values from the channel. That means there won't be any blocking wait. There won't be any pause in the main goroutine. So what will happen? The goroutine display will execute, but before it return back, main will be completed. So there won't be any output or response from the goroutine. So just the main goroutine will be printed here. Display goroutine will not at all be printed. So in order to keep the display goroutine in our control, we need to keep the execution blocked with the read operation. Right now we are using the read statement here. I am now planning to read to some particular variable, so I am using num is the variable I am using here. fmt.Println num. See here 10, this is the value. So I am reading the value from the channel and printing it here. So my channel is supplying some values. If I am interested with that particular value, I can assign it to a variable and use the variable for some operations. But if I am not at all interested with the value, but I just need to read something so that it will keep the progress blocked and all, we can just use it as it is without any variables. Now I am assigning it to a variable num. That num is being printed, so the value supplied to the channel my channel in the display goroutine is being printed here in the screen, which is 10. So this is what about basic things, basic concepts about channels. We have a lot more things we are going to see in the channels. We have unidirectional channels, we have bidirectional. Of course, by default all these channels are bidirectional. That means we can read and write, we can do both the operations in channels. So by default channels are bidirectional. So we can have both unidirectional and bidirectional channels in Go programming language, and also we can have buffered channels. So we are going to see lot more details regarding the channels in the forthcoming sessions. So if you have any doubts or confusions or any suggestions, please write them in the comment section given below. Please click the subscribe button. Don't forget to click the bell button. It will keep you updated whenever a new video being posted by me. Thank you for watching. Let us meet in the next session.